we're continuing with where we kind of left off last time, which is find the 6 trig ratios when you're just told one of the 6, in this case, the cosecant, and what, in this case, the quadrant it's in. So I'm told the cosecant of theta is 4 and the quadrant it's in. And we're basically going to be using these guys. Right. Now, since the angle is in quadrant 1, doesn't that make everybody positive? So I know that all my answers are positive. I'm going to rewrite this guy and I'll put it on a separate line just to emphasize it. I'm going to write it like that. And since everybody is positive, we can just, that means X, Y, and Z are all going to be positive. So the first goal is to find out what these numbers are. Now, if you look at the cosecant, isn't the cosecant the R divided by the Y? Isn't that one of the forms? So in this case, R divided by Y. Now, does it not make the R 4 and the Y 1? And because it's the first quadrant, don't I know those are both positive numbers? Because in some of the questions, couldn't, not that one, that's always positive, but couldn't in some questions this be -1? Right, depends on the quadrant. Now, I've only one guy to get, and that is X, and that's where we use this fella. So X squared plus Y squared equals R squared. X squared plus 1 squared equals 4 squared. X squared plus 1 equals 16. That makes X squared 15. And then we take the square root. But X could be plus and it could be negative, right? And haven't we already decided that all these ones, because it's in the first quadrant, is positive? And are you happy why I wrote plus square root of 15 and not the alternate choice, which was negative? So far, so good. So your goal when you get this type of question is to write it a fraction if it's not, pick whichever is the relevant guy, so you can find 2 of the 3 variables, right? So you'll get 2 of these pretty quickly. And take note of the quadrant it's in, because won't that quadrant tell you who's positive and who's negative? Just for argument's sake, can we pretend that that was the 3rd quadrant? Just for argument's sake, right? If that was the 3rd quadrant, wouldn't the X be negative and the Y be negative as well? Right. If it was in the 2nd quadrant, wouldn't the X be negative, but the Y value would be positive? So we have to know what these are. In this case, they're both pluses. Now, once you've got that, and I'm not going to finish the question because I think the hard part's done, don't you just say sine of theta is 1 over 4, right? Y over R. Cosine of theta is square root of 15 over 4. Tangent of theta is 1 over the square root of 15. Don't you basically use these formulas and get the numbers from here? The only thing you might want to look at is square root of 15 over 4 is okay, right? That's a good answer. But suppose you got a question which was 4 over the square root of 15. We don't like that as an answer. Even if WebAssign takes it, it's good practice not to accept that. Don't we rationalize the denominator and call it 4 root 15 over 15, because we consider that a better version of the right answer. So bear that in mind. Never leave a fraction with the square root in the bottom if you possibly can't help it. Also, sometimes, don't you get an answer like the square root of 8? And we don't like that as an answer. And let's put a number over it. Square root over 4, right? Let's suppose we got that. WebAssign again might take it. I don't think it does, but it might occasionally take it just because it can. But that's not a good version of the square root of 8. Can't that be called 2 root 2? And then sometimes, and this is one of them, it becomes that. So whenever you're doing find the 6 trig ratios, will you always bear in mind style points? That's what I call this. Make the answer look as good as it can. So don't have square roots in the bottom and don't have square roots that could be simplified down, right? And you do that, you will be fine. Are we comfortable with this process now that we've seen a lot yesterday and one today? Do I need to do one more, or can we move on to the next thing? Just shake your heads or nod or do something. That'll do. I'll move on. If you don't like the answer, you will now speak up and say, can we get another one, please? Because I'm not 100% sure. Okay. Now, the next questions are really not that different, but just for completeness sake, I'm going to do it for you. Sine of theta is equal to 8/17. And you're told that it's an acute theta. Isn't an acute angle an angle between 0 and 90? Haven't they just told you it's in the first quadrant? Would you agree? They've told you where it is. Now, what they want you to do that's different is they want you to build a right-angled triangle that has this information. Okay, now, are we good? Right, now, I could do the X, Y, R stuff, but since it's an acute angle, couldn't I simply just say opposite hypotenuse? Right, 8/17, opposite over hypotenuse. How about Y over R? Right, if that makes you feel better. Isn't there one guy missing? Don't we need to get the third side because they want the angle? They want the whole triangle. Wouldn't that be Pythagoras? Now, if you want to, I can keep it as x squared plus y squared equals r squared, in which case this guy is essentially x, the horizontal distance. So it's going to be x squared plus 8 squared equals 17 squared. I don't want to risk 17 squared in my head. I know it ends in a 9, but that's about all I can tell you right away. It's 289. Subtract 64 from both sides, and you get 225. And then you take the square root of 225, which ends up being a very nice, and wasn't expecting it, answer. Now, what will that look like in your WebAssign homework? There are 4 triangles in question 25, and one of them is this guy. And there'll be a little circle here, and you shade in the dot. That's how you do it. So you don't actually physically draw on your computer that picture. Don't you just pick the picture that looks like that guy? And that's how they get around it. And they have the other 6 trig ratios, right? These guys that you can do later. I could kind of start this one, but not do it totally. It's also an acute angle. And secant theta is that guy. I don't think secant thetas work well with this. So I'm going to find out what the cosine of theta is. What is the cosine of theta if the secant is 16/3?
3/2.
You just turn them upside down. Now, for a cosine, isn't it adjacent over hypotenuse? In which case, 3/16. And then can't you get that guy by Pythagoras and then write down your ratios? So if they tell you sine, cosine, and tangent, and that it's acute, can't you just do opposite adjacent if you want? If you don't like opposite adjacent because you're kind of in this mindset, won't that be called X? This will be called Y, and that'll be called R, and you'll get the same answers. Right? If you want to call the horizontal line X, the vertical line Y, and the hypotenuse R, it works equally well. I think there are about 3 or 4 questions look like that, and then it's just some videos that you watch and answer, so I don't need to do that. So we're finished that section. Done. And now we're moving on to our final section for this week. And it's section 6.4. Inverse function. in right angle triangles. In a lot of ways, this is just review, because we've actually done what they're asking you to do here. Remember those questions where you got a right angle triangle, or you knew a side and an angle and they asked you to find another side, or you knew two sides and they wanted you to find an angle? This is essentially what's happening here, right? They're just returning to it, and they do it a little bit more detailed, but it's not, most of it is not new, right? It's just stuff you've seen before. So I'm going to look at it just from a different way, right? Suppose I give you a triangle, and I'm trying to get the numbers right here. Make that 12, make that 5, and that's 13. So I'm going to give you all three sides of a triangle. And I'm going to call this angle up here theta. So I want you to think back to SOHCAHTOA again, right? So we're back to SOHCAHTOA. Now, in this triangle, would you agree that this side, which 12 is called the opposite, the side that's length 5 is called the adjacent, and this side here is called 13. Would you agree that's not new stuff? We've done this before, right? So they give you a triangle with theta, and we need to name these sides. Now, if I said to you, what is sine theta equal to? I hope you would say, oh, it's the opposite over the hypotenuse. And so you would be saying sine theta is 12 out of 13. So far, so good. Great. Now, how would I find on my calculator what the angle theta was equal to?
You just take the inverse of sine 12, 13.
And that's what they want you to do. They don't even want you to tell me what the answer is. They just want you to write that down. Okay, so if you wanted to know the size of angle theta, wouldn't you just find the inverse sine of 12, 13? You remember doing that a couple of questions? Nothing too new, it's just maybe the way they phrased it. So here's another kind of different issue. Couldn't I find the cosine of theta in this triangle? Because I know all three sides. And won't the cosine be the adjacent over the hypotenuse? And so that makes the cosine of theta is 5/12. So from this piece of information, the cosine...
Because you said adjacent over hypotenuse.
Thank you. You caught it in time. 5/13. If the cosine of theta is 5/13, if I wanted to find the angle theta, wouldn't I now be finding the inverse cosine of 5/13? Now, if I kept on doing that, how would I find theta using a tan? So I'm not writing down the whole working here, but you should be able to have a good chunk at it. What would theta be in terms of the inverse tan?
12 over 5.
Wouldn't it be opposite over adjacent? Right. Now, those three guys you probably used from time to time, but they're not the only guys. There are three more guys that you probably will never use in any practical way, but it could happen. There is an inverse cosecant, there is an inverse secant function, and there is an inverse tan function. Would you agree you probably never use those three, but they're there. So based on opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, couldn't you have a good guess at what these three fractions should be? So If the inverse sine is 12/13 gets you my angle, won't the inverse cosecant of 13/12 do the same job? If the inverse cosine of 5/12,
How do you type cosecant, secant, and cotangent in your calculator?
oh God, you have to go. Nobody would do it for starters, but if you had to do it, you go to a button called catalog in your calculator, and you scroll down it, and eventually you'll find it. Anybody in their right mind would only use these three. Would you? These three are easy to find, aren't they, on your calculator? And since all 6 work, you don't need to do it 6 times, do you? I mean, this is him just saying, like, you could do it 6 different ways if you wanted to. But I would put, you know, if you told me a triangle and I knew all the sides, wouldn't I pick this one probably? Suppose you only tell me 2 of the sides. Isn't that more likely? Now, when you tell me 2 of the sides, isn't there only one candidate for the answer if I don't want to give myself extra work? Which one of the 3 would I use if I knew the adjacent and the hypotenuse?
Cosine.
I know, yeah. Remember saw catoa, cosine. Back to this guy, so it's 5/12. So can you do them in your calculator? Yes. Do you want to? Definitely not. If you're really keen on it, I could show you. I'll probably show you once and then never do it again. There is a catalog. It's on the 0 button here. So blue button, catalog. So if you can't find something on your calculator, right, you just can't find the button, but you know it's there somewhere, hit catalog. And it's kind of alphabetical. So what am I looking for? Inverse cosine, so inverse cosecant. Okay, so hopefully it'll be in the C's. Nope. Oh, okay. Come on, I know you might be. We're close to it. That's the inverse cosines. None of them inverse cosecants. Oh, making a liar of myself. I'll go, it may be called inverse cos or something. I'll go to I's and then I'll give up if it's not there. You didn't realize there were so many buttons on your calculator, did you? A, F, G, almost the I's. That's it. So it doesn't even exist in your TI-84, which is good because I would never use it anyway, even if it did exist. I just wanted these 3 because they are easy to find. Are you comfortable with that question? Right, so if I gave you a triangle with all 3 sides, could you find these 6 different ways to get the missing angle theta? Do you want to see another one of these, or are you comfortable with these? We're good, right? Good, because I think you only get one question like that. So I don't want to spend a lot of time on it. Now, we're going to look at how to find the exact value of, say, something like that. Basically, when you use the inverse sine function, aren't you finding an angle, right? You're finding the size of an angle. Now, this particular one, you could do in your calculator, but I want to show you how you would do it in general, because not all of them work with your calculator. So I'll make sure that I'm in degrees, which I am. And I'm going to do the inverse sine. So blue button sine, there's the inverse sine. It's going to be √2 divided by 2, and 45 degree, oops, I put √3 for some reason. Well, that works as well. There, put it in. I meant to say √2 over 2, and the answer you get is 45 degrees, or if you prefer in radians, 5.4. But let's look at it from a different perspective. What you're looking for here is what angle has a sine equal to √2 over 2. Now, if you imagine that we had our unit circle, remember that big guy that you probably got a good copy of now? If I went and said to you, what's the exact value, or what angle has √2/2? Wouldn't you find a guy over here at 45 degrees? And that would be your answer. Let's try that without a calculator then. What angle, and there's a couple of answers, but we only want one of them right now. What angle gives you a sine of 1? What angle has a sine of 1?
90 degrees.
Great. What angle has a cosine of -1? That's how you should read them out to yourself. What angle has a cosine of -1?
180.
And if the question said in radians, don't you just find the 180 and then you turn it into radians later? That's probably the easiest way to do it. Now, suppose we introduce a negative into the problem. So what angle has a sine of -√2/2? If you go looking for an angle who's got a sine who's -√2/2, they're going to find two of them, aren't you? If you look hard. Which quadrants is the sine negative? Which quadrants is the sine negative?
3 and 4.
3 and 4. Now, if you go looking for your unit circle, isn't there an answer over here? And there's an answer over here, agreed? And the one over here is, I believe, 315 degrees, and the one over here is something like 225 degrees. Yet there's only one correct answer. This is a function, and because it's a function, for any given value here, you can only have one answer. So what they have is they make up rules about which of the two possible answers you should pick. And this is where it gets messy. So let me tell you where you go. For the sine function, right? For sine theta. If theta is positive, pick the angle in the first quadrant. If theta is negative, pick the angle in the fourth quadrant. So in this case, it would be 315. And that is the rule that you're going to use to decide which of the two answers. Because if you pick any number, if I went and said to you now, sine of theta is √3/2, do you know there's two different answers that have that value? And so you have to pick one of them. Now, for a cosine of theta, if theta is positive, pick the guy in the first quadrant. If theta is negative, and if the cosine is negative, it's negative in the second and third quadrant, you pick the second quadrant. And this is just things you have to memorize. And then for the tangent function, that's the only one I'm interested in, is sine, cosine, and tangent. If theta is positive, you pick it in the first quadrant. And if theta is negative, you choose the fourth quadrant. Now, if you want to simplify that a little bit, don't you only need to worry about what to do when the guy you're looking at is negative? So when that guy is negative, the thing inside is negative. Fourth quadrant, second quadrant. Because if it's positive, don't you always get the answer in the first quadrant, right? So that's it. Now, I should be putting little inverses on these guys. There we go. Well, let's try that out. The inverse tan of a half. Let's pretend that exists. That's positive, agreed? So won't my answer to theta be in the first quadrant. If I asked you to find the inverse tan of, say, -√3, which quadrant would I be looking in? The tangent is a -√3. Which quadrant is the angle?
The
Fourth.
fourth one?
It's in the fourth quadrant. So if you imagine your unit circle and you go down here into the fourth quadrant, won't there be an angle here that has the value that the tan of that angle theta is -√3? And there's another one that away up here that you don't, what am I saying, fourth quadrant? You've got me there in the wrong answer. There is one up here in the second quadrant.
You told us it was in the.
I
fourth
did,
quadrant.
and I should have. If I had a brain, I'd be dangerous. I switched them around. I apologize. You're doing what I told you, and I told you wrong. So it wasn't your fault you said 4, because I told you you should have. Although I did say the right answer here. Going figuring it. Yeah, it is the fourth. Darn it in space. I'm talking myself out in the game. I was right the first time. It is that one. Forget that. It is that one. Now I'm going to do another one, and this time I'll be careful and get it right. The inverse sine of √2/2 is in the fourth quadrant. So when you get your magic unit circle and you find that guy, isn't it the answer 315 degrees? And that's the guy in the fourth quadrant that you can choose. How about, and I should be putting a negative there. How about this fella? When the cosine is negative, shouldn't I be looking in the second quadrant? And if you do your unit circle and you find the guy that's here that has a cosine of that number, you will get, I believe, 135 degrees. Okay. Now, as long as it's these answers, we are pretty much good to go, because let me do that one there, right? The inverse cosine of negative square root of 2 divided by 2. If I've done this correction to be 135 like I predicted. You see it? Now, what about this one? The inverse sine of negative √2/2. If I did that one correctly, shouldn't it be this answer? So let's see what we get. And it's not actually going to say 315, but I'll show you how we get around that. It is still 315. It's just the calculator's not very clever. And the answer you're looking at should be -45. Do you see that? Now, if maybe the next generation of calculators will fix that. What angle is -45 degrees? Isn't it 315 degrees? So it does work, right? But it ain't always perfect. It was good for the cosine, wasn't it good? It got the cosine the same one that we had, but in the sine one, it gave you the same answer, but only in a rather awkward way. Are we good? Which quadrant is the inverse tan of 1 in?
1.
Agreed? First quadrant. If you go in your magic circle, right, your unit circle, would you agree that 45 degrees does that? And that would be an answer. that this is equal to 45 degrees. Right. I made a bit of a pig's meal over here, but hopefully we fixed it for you, right? So inverse sine, inverse cosine, inverse tangent. There's only one answer allowed for each, and the answer that you typically get depends on whether it's positive or negative, right? And we have rules about which quadrant the answer is in. So a cosine that's negative is going to be in the second quadrant. A sine or a tangent that's negative is definitely the fourth quadrant, which I almost talked myself out of. Are we good? Right, the next stuff is going to be dead easy. And in fact, so easy, you'll talk yourself maybe out of doing it correctly. You're being asked to use your calculator to find the inverse sine, inverse cosine, and inverse tan of various angles. For instance, I'll just make some up. The inverse sine of 0.80, the inverse cosine of negative 0.31, and the inverse tan of, I don't know, 55, right? And you just make sure that your calculator, I'm assuming that they want the answer in degrees because they don't tell me, so I'm assuming it is. I'll check in a minute if that is the case. So you just go inverse sine of 0.8 and to 1 decimal place, 53.1 degrees. The inverse cosine of negative 0.31 is 108.1 degree to 1 decimal place. And the inverse tan of 55 is, oh, that's a bit weird. To 1 decimal place, it's actually 89.0. Would you agree those kind of questions are going to be dead easy? Now, there are two things I want to check before we continue. The first one is I want to make sure that the answers are in fact in degrees and not radians. So why can't I get answers to this? Oh, there we go. And guess what? I should have checked earlier. Okay, they want the answer in radians. No biggie. Hit mode. Go to radians. And then just do it again. Okay, inverse sine. I'm not blaming myself this time. Shouldn't the question have said in radians? I'm looking at it. Oh, shooting space. Guess what it says? In brackets, in radians. So it is my fault. Okay, well, back to the question. So this one would be 0.927 to 3 decimal places. Would you agree that this type of question is just plug it in and write down what you see? Right. So if I had to find the inverse tan of negative 35, the answer you would write down would be exactly what you see. So roughly that. If you wanted to draw that, that would actually be an angle down this way, wouldn't it? But we're not being asked to draw it, just find its value. Here's a sneaky one. I want to find the inverse sine of 3. Is that even possible?
My calculator says no.
Correct. Do you know why it's impossible? It's because when you look at the value of the sine functions and they're in the unit circle, aren't all the numbers less than 1? So the sine and the cosine have to be either plus or minus 1. So that's okay. They even tell you what to write down when that happens. Just write down undefined. So far, so good. Little hiccup on radians and degrees. Let's see if I can do the next question without a mistake. You are given, and this should be deja vu, a right angled triangle, an angle over here of theta, a 34 and a 16. Can you remember the questions where you had to find missing sides and missing angles? This is basically, this is us returned back to that question. So let's go through the steps in case you need reminding. The first step is to name the sides. So Sokatoa, I better put that up there, you remind me. 16 is called the opposite. The 34 is called the hypotenuse. I really don't know what that is, but if I wanted to know its name, it's adjacent. That's step one. Step two is choose the correct ratio. Using Sokatoa. Right. Which one of the 6 trig ratios uses an opposite and an hypotenuse?
Sine.
Sine.
Agreed. So the sine of theta is opposite over hypotenuse. The sine of theta is 16 over 34. And this is where the inverse thing kicks in. To find theta then, don't you just find the inverse sine of that guy? And this time it is in degrees. Oh, bear that in mind. They jump around. Sometimes they want radians, sometimes they want degrees. Then I get caught out today by doing degrees when they wanted radians. Right? If I left my calculator the way it is right now, which is in radians, this will not be the answer they want. So I have to change it back to degrees. So I would do that as one of my checks. If it doesn't work, make sure that you're in degrees or radians, whichever's been used. And inverse sine of 16 over 34. And to how many accuracies? To 1 decimal place, they ask. So 28.1 degrees. Are we cool with that question? Pretty straightforward. Kind of a way back to last week almost. Here's another one. And this one is like 13. I think they deliberately make these weird angles just to make it hard for you to see what the heck's going on. But there's a right angle there. The angle you're going to be finding is this fella. It's going to be in degrees again. And this thing is 50. And this thing is 70. So this is going to be opposite. And this is going to be hypotenuse. And I don't really care that that's adjacent. So I'm not even going to write it in this time. Because the sine uses opposite over hypotenuse. The sine of theta then is 50 over 70. And so theta is going to be the inverse sine of 50 over 70. Since all these questions are in right angle triangles, isn't theta always going to be in the first quadrant? So we don't need to worry about that earlier stuff. So I'm going to clear and go inverse sine and do 50 divided by 70. And the answer I'm looking at is 45.6. Are we good with that question? In a lot of ways, isn't that a lot easier than some of the stuff we've done? It's really just change the numbers and you're good. And now we're going to return back to the guys that we were talking about, where there are two possible answers. Remember this table? And they are going to change the story on us, because in question 15, they are asking you to find all the angles from 0 to 360. So we're not just going to find the one angle that the inverse tan gets you. We're going to find the other one as well. And that gets quite complicated for some questions. So here goes. I'm being told that the sine of theta is equal to 5/6. And I'm going to find the inverse sine of that, and that'll tell me one of the two angles. And that's the easy bit. The next bit's where the tricky part starts. And that is, put it down here, I guess, 56.4 degrees. I'm a kind of visual person, so I do this. I draw roughly what that would look like. You agree it's in the first quadrant, looks like that. If you had your unit circle on top of this, right, you found this answer, and this is the one that's in the first quadrant. Which quadrant do you get the other place that the sign is positive?
Quadrant 2.
Yes. Now, what you got to imagine is another guy coming up here, like there, right? And that guy there would also have a sine of 5/6, right? There are two answers, right? There's this one, we got that from the calculator, and now we have to go hunting for this one. And we use symmetry. What angle do you think this red angle here is? What do you think it is?
56.4.
And it will be. So whenever you have an angle, right, whatever it makes with the x-axis, the other angle will make the same size with the x-axis. So if it's down here, that bit there will be 56.4. If the angle that you want is down here, this angle will be 56.4. Now to finish with, because I did say it was tricky, isn't that the second angle? What is that green angle then?
Did you just take 90 minus 56.4?
Change the number to 180 and you've nailed it. So it's 180 take away 50.
Okay, yeah, that makes sense.
Right? And so you 180 take away 60 and you get 23.6 degrees. And now we have solved that question. But you agree that's a little bit tricky. The first one you probably get for free off the calculator. The second one is going to be a bit of a stretch.
Why are you taking away 180 degrees?
Okay, this picture is kind of messy. So if I just draw this piece here, the angle I want is that guy, right? So I know this piece is 56.4. 180 would be from there to there. So 180 take away 56.4 is the guy I want. So,
Okay.
right. So if you went all the way around, it's 180, and then you come back another 56, and that's the one you want.
Oh, thank you.
Right. Let's try. These are a lot of different variations in this, so you have to kind of see quite a few. I'm going to do a negative version of that. How about the sine of theta is -1/4, right? And we want to find the two answers, right? All of them want this, the two answers from 0 to 360. Well, I'll go to my calculator and hopefully I'll get one of the answers, although I'm going to have to tweak it. The inverse sine of negative 1/4 ends up being negative 14.5 degrees. I've rounded it off. But that is not in the range 0 to 360. Agreed? Now, if I draw this fella, when you get negative 14.5, isn't it this angle here? But the one I want is that angle. So far, so good? Right. How will I find what this is equivalent to? Right. It's coterminal angle, if you want to call it
that. If you had 360.
You do. And if you add 360 to this, you get 345.5 degrees. And I'll put a little box around that because that's one of the two answers. So far, so good? Now, I'm going to draw another picture because there's just too much happening in this picture. God, that's horrible. I can't work quick. Yeah, that's much straighter. We have just found that angle, right? It ends up being 345.5. But isn't the size of that angle 14.5? Which quadrant is the sine function negative? Well, it's negative in the fourth quadrant. We already found that one. But where's the other place?
And the third.
In the third. Now, I talked about symmetry. I'm going to talk about it again here. The angle that you get in the other quadrant will be the same size that it makes with the x-axis. So this angle in here, from there to there, is also 14.5. So far, so good? Now, what is that angle if you measure it the usual typical way? What size is that entire angle? It's not 14.5, but what is it? Or how do I get
Would
it?
that be 194.5?
Okay, so you add 180 to it, and you get 194.5. Do you see that in those two examples, the way you found the second angle was it was in a different place and you had to do a different kind of calculation? In that previous question, didn't we have to take this away from 180? But in this question, didn't we have to add it to 180, right? So you have to be, what's the word? You have to look at each question on its own merits because they're different. And we've just done the two versions of the sine. I'm going to try the two versions of the cosine. Let's do the cosine of theta is nothing 0.3. And we're being asked to find the two angles that have a cosine equal to that, and it has to be from 0 to 360. So to get the first answer, I'm going to find the inverse cosine of 0.3. So that bit's probably going to be the easier one of the two to get. In this particular case, to one decimal place, it's 72.5 degrees, and I'm happy with that. And now I'm going to try and do it the way I kind of did the last one, do it visually. In the first quadrant, we've just found one of our answers. It's 72.5. In which quadrant is the second angle going to be? Where is the cosine positive again? It's positive here. But which quadrant is it positive again?
Is it the fourth one?
It is the fourth one after all those changes I told you. Yeah, it's the fourth one. Now, if you do my, maybe a little dotted line will help. By symmetry, don't all the angles make the same size with the x-axis? So won't this one be 72.5 as well? Now you have to figure out what that dotted angle looks like when you measure it the typical way. So what calculation would I use to find this 72.5 if I measured it anti-clockwise as I have.
Did you do 360 minus 72.5?
Right. Have you noticed that they keep changing the calculation to get the other one? It was 180, add something. It was 180, take away something. Now it's 360, take away something. You see, it depends on the question, what you need to do. That's what makes this tricky. Agreed? Yes.
Okay, I'm a little confused. I get the first part, but
Yeah.
I don't understand, once we go to the second part, finding the other angle, which, like, what angle we're looking for and why it changes.
The angle that we're looking for in this is the second angle, the place where the cosine is positive. So that's in the fourth quadrant. So your question is which angle I'm looking for. I'm looking for this angle, but I'm wanting to measure it from 0 in an anti-clockwise direction.
Okay, so you look for the angle where cosine is positive again.
Yes. And then
Okay.
you try and measure it this long way around. So this fella here is pretty messy, so I'm going to do that in my calculator. I have 72.5, and the answer I get is 287.5. Now, the first two questions I did were a positive sign and a negative sign. This is a positive cosine. I'm going to do a negative cosine now. And then lastly, I'll do a positive tan and a negative tan. That means we've shown you every single combination that could happen. So at least you've got one example of each situation. So for this one, we're going to do a cosine that's equal to a negative number. So the cosine of theta is negative 0.712, just because it can be. And again, we're being asked to do it in the 0,360. So there's my negative. So we want to find the inverse cosine of negative that guy. And I go to my calculator and I do inverse cosine. And I type in negative, which is a button down here, 0.712. And we are looking at 135.4 degrees. That's one of the two answers. It's between 0 and 360. I can use it. Now, on this picture, I'm going to put that angle, or roughly where that angle goes. Would you agree it's somewhere in that general region? Would you agree it's in the second quadrant? And that angle is 135.4 degrees. Now we have to figure out which quadrant, which other quadrant is the cosine negative.
It'd have to be quadrant 3.
It has to be quadrant 3. Remember, all sine, tan, cos, that kind of. Right. So nothing's an extra little bit of problem. Isn't it the angle that it makes with the x-axis is the same? Right, all of them have that. This angle here is probably not the one I should be using then. Wouldn't it be easier to find this angle in here because it's the one I probably want to use? Because whatever that angle is, isn't this guy here going to be the same size? Now, I could do it two ways. Couldn't I take this angle and then just figure out how much it was going backwards? Couldn't I do it also by just figuring out what that is? But I'm going to go this way. So if this is 135.4 and this is 180, won't this be the piece that's left? And the piece that's left, I believe, is 44.6 degrees. Are you comfortable that that's 135, that's like the rest? Now, won't that make this guy also 44.6 degrees? And now my picture is getting decidedly ugly because there's so much going on. But don't we want to measure what that is the usual way? So this angle here, the one I'm going to make blue now, is the one measured from 0 all the way around anti-clockwise to here. What calculation will I do to get that second answer?
That'd be 180 plus 44.6.
And that ends up being 224 0.6 degrees. Now, let's say you're not 100% sure that this is right. You can check it. Can't I just find out what the cosine of this is? And it better be that guy, or at least rounded off that guy. So the cosine of 224.6 should be dead close to negative that number. Would you agree that's pretty close to negative 0.712? So I'm just saying, you can actually check. If I went back and did the others, I bet you they all worked, right? Just two more guys to do. I'm not sure I've got time, but I'll try. Let's do the tan of theta equals 4. Inverse tan of 4 gets me my first answer. And the inverse tan of 4 is about 96 degrees.
Wait,
96.
96? Isn't it 75 point
What man?
or 76?
Oh God, I'm looking at the decimals. Can you tell I can't do things quick? Have you realized that? The quicker I go, the more I make. It's 76, you're right. I should have realized that it's positive. So doesn't that make this angle 76 degrees? And it's in the first quadrant. Which quadrant is the other answer then? When is the tangent positive again?
Third.
Okay. Now, if you imagine this being 70, and I'll make it a different color, won't the other angle be over here in the third quadrant? And won't it also make the same 76 with the x-axis? So to get the second one, don't you just go 180 plus another 76? And so that one would be 256 degrees. Kind of rushed, but I'd be cool with that one. One off the calculator and the other one we have to build a little picture.
So I have a quick question, right?
Go.
So if we're given tangent of theta is equal to -4, right?
Yeah.
Then we would, to find the second angle, we would find the other quadrant that tangent would be negative in, correct?
Yeah.
Okay.
And I bet you if you did -4, why don't I do that one? Because I kind of know the answer. So imagine as our last example, we were doing this one, right? You would get this in the calculator and will you trust me, it would tell you negative 76 degrees. Right, remember the sine one did the same thing. So
Yeah.
won't that one will correspond to an angle down here of 76 degrees. But as we measure it, we would call it 360, take away 76. So we would call it 284. Now, which quadrant is the other place where the tangent is negative?
Quadrant 2.
And won't we draw another line like that and say, oh, you are also 76 with the x-axis. See, it's all about the angle you make with the x-axis is the same. And in this case, wouldn't the second answer then just be 180 take away 76, and that will equal to 104 degrees, and we are done. Whew. Thank you for hanging in there, because there was an awful lot of stuff going on. Hopefully you can, when you've got peace and quiet, you can go through all 6 combinations slowly and try them out yourself and check them with the homework questions and see if you're doing right. So put your last name down and bye-bye. I'll hang about for any questions.
So next Monday, I believe that's a holiday.
It is.
So do we not have class that day then?
Correct. Also, there will be a change. Someone in another class suggested this, and I thought it was a good idea. I will make the homework due midnight Monday, and I will make the test 2, due midnight Monday. Since it's a holiday, I can move it another day.
Sweet.
Okay. Okay.
Will homework still be available on Monday because I'd like to get started as soon as possible?
Which homework are we talking about now?
Next week, sorry.
You'll have to shoot me an email and I'll make sure I do that. I can't really do it right now because I've got other things I have to do and I will forget. I'll be honest with you, I forget things. But if you shoot me an email Monday, Sunday, I can do that. It's not a biggie.
All right, sounds great. Thank you.
Have a good
Okay.
weekend. Thank you.
You're bye, Ali. You're welcome. Any
Um,
questions?
I have a question for you.
Go for it. What you got?
So I have a question on the 6.3 homework. Maybe I can
Share the screen?
show it to you.
Oh, I can share the screen. You ever done that? Okay. I've just given you permission to share the screen. So you want to see if you can do it? Otherwise, we'll just look at it where you did.
I can't share screen just right now because I'm on my phone and I don't have the.
Okay, so you're going to have to do it the other way. Show me that thing up to the screen then.
Okay, it's just I don't know if you'll be able to even read it. It says the area of a triangle with side lengths A and B
Uh-huh.
and with included angle theta is given by the formula A equals, and then it wants that formula. So the area that
Right.
Yeah.
So you need to go looking for that formula. It's a half AB sine theta. But
a
if you
half,
looked at A times B times the sine of theta. So if you looked up the textbook, it would do it. Did they have a little thing like watch or go there or something? They very often do in those questions.
I think they had to read it, but I was
Right.
having
If you
trouble
go to
finding
read it and it's not always on the page that they take you to, but if you scroll 2 or 3 pages later, you'll probably find that formula. Right. So the
Okay.
area is a half AB sine theta. And that's what you would have found if you went there.
Okay, and have we been finding the area of triangles, or are we just?
We
Or just-
haven't, but they're just saying, look, here's a formula that uses a trig function for getting the area. Just use it and get the answer.
Oh, okay, sounds
Right.
good. Thank
So
you.
I mean, there are other formulas for calculating areas of triangles that you could have been told. But in this case, they just told you that one. There's a cool one called Heron's formula, if you're interested, which tells you how to find the area of a triangle only using the 3 sides, and it doesn't even need to be a right angle triangle.
Oh, that's cool.
Right? So, yeah, it's just an application.
All right, thank you so much. Have a nice weekend.
You too. Bye-bye.
Bye.
Hello?
Hi, question.
Yeah. So I guess I'm a bit confused. Like,
Mhm.
how do we know in which, like, so sometimes we do 180 plus whatever angle we have.
Yep.
Sometimes we do 360 minus whatever angle we have.
Yep.
How do we know in which situations which to use which?
Okay, it depends on the picture that you draw, how you're going to do it. So let's imagine that we've got this triangle and the guy that we're going to find is this angle in here, right?
Yeah.
So that's the second angle. We will know this angle here because we've already got the first angle, and this angle here is whatever angle it makes with the x-axis. So let's suppose we're told this is 31 degrees. So this is my second answer. If I wanted to find or tell people what this angle is, right, this fella here, it's 180 plus another 31. So that would be an example where you would add 180 to the answer, right? If you get a picture looks like this. Now, suppose you got a picture where the second answer was up here, right? It's in the second quadrant now. You're going to find that angle, but you already know the angle that it makes with the x-axis. You always know the angle it's going to make with the x-axis, right? That you get from the first answer, right?
Mhm.
Now, what would you do to get this one then?
180 minus.
Right.
31.
And do you see, yeah, do you see the difference between those two is just where the thing is, agreed?
Mhm.
Right, now there are other possibilities of where that thing is, so let's show you another one. Let's suppose that the angle that you're interested in is over here. And so the one that you're going to get, right, is that angle. But you still know that this is 31 degrees, right? As you will for all of them, right? You'll still know that number. You always get that first anyway. Now, in this case, wouldn't theta be 360 and then pull back 31? So it's a subtraction.
Yeah.
So the question is, when do I do one or the other? This is a situation where you'd add 180. This is a situation where you take it away from 180. And this is a different situation where you subtract the answer from 360. So in every one of those cases, draw a little baby picture like this. This is what I tend to do. Put it in the quadrant, you know it's in the fourth, or you know it's in the second, or you know it's in the third, right? It's going to be in one of those three quadrants. And then put that little angle there, because you'll know it. How will you know it? Well, you know when you do the first angle, theta, you find the size, it's 22 degrees, or it's 31.
Yeah.
Or it's 150. Well, if it's 150, because that can happen. So if you get the first angle and you find out it's 150 degrees, don't you still know what the angle it makes with the x-axis is?
Yeah.
So that would be the 30 that would go here, here, or here, depending on the question.
So I'm just kind of noticing this, but the kind of pattern I'm seeing is that depending on where the second angle is,
Yep.
is kind of how we determine the math. So like if it's if the second angle is in the fourth quadrant, we 360 minus the second angle, and so on and so forth with the other ones.
Yeah, that's exactly it. That's what you're saying, and that's what you should be doing. So in a way, there are really only three things that can happen. That's once you know the first angle. You're going to have somebody in the third quadrant, you're going to do 180 plus it. If the angle is in the second quadrant, it's going to be 180, take it away. If it's in the fourth quadrant, isn't it going to be 360 and take that angle away? And that's the three combinations that happen. Are we good?
Yeah.
Anything else?
I do not think there is anything else. So thank you.
Okay, I still have office hour at 10 o'clock on Friday. So if, although it's not a class day for you, if you have questions, I'm available. You can drop in then.
Okay, thank
10
you.
o'clock Friday. And the link to it is in Canvas. It's just a Zoom link like everything else.
Yeah, okay, thank you.
Okay. Renee, you got a question?
Yeah, a few.
Okay, go for it.
I don't know how to change my calculator, like between like the radians, like you were saying.
Have you got a TI-84?
Yes, I've got a TI-84.
Oh, good. Then it's easy to show you. Hit the mode button. Right. So you should be looking.
I see it.
You see it? Now, you scroll with the little mousey guy down, the little cursor, and you go along. And if you want degrees, you hit enter. And if you want radians, you highlight it and then you hit enter. And that's it. It's done.
And then I also wanted to know why we're doing that little twisty thing that you were just demonstrating with the other person who just left. Like, I don't know. Like, I don't know why we're going all the way around and looking for.
Oh, what we're being asked in this bunch of questions where these little twisty things are coming from is we're being asked to find two angles that have a sine, a cosine, or a tangent equal to something. So the questions would start off with something like, let's do one. Find the two angles. Where the sine of theta is equal to 0.123. Now we know, because of the unit circle, that there's two angles that have that as their sine. Right? It's not just one angle.
I don't remember how I know that.
Okay, let's show you how that
I'm having a brain moment.
Okay, if you do a unit circle and you pick, let's say that guy at random, and let's suppose that guy was 1/2 √3 upon 2. That would be for that particular one. What would that be? Let's see, is that 30 degrees or 60? That would be for 60 degrees. So if you looked at 60 degrees, you would find out that the sine of 60 degrees is 1/2, right? Or whatever, right? Actually, √3 upon 2, if I'm being precise. Now, there is another place where that also happens. Now, when you do the unit circle, right, you have an x coordinate and a y coordinate, and the sine of an angle is its y coordinate. So when I look at this, I say, if that has a y coordinate of √3/2, isn't there another guy over here who also has a y coordinate of 3/2? And you see that means that there are two different angles that have a sine of √3/2. And that's true for every single angle that you can think of. If you have an angle and the sine is 1/2, there are two places in the unit circle, two angles that have a sine of 1/2. Okay, now you say, well, what is the second angle? We measure angles starting at the x-axis. So this second angle is all the way around to there. And if you looked it up, you'd find out that that one was 120 degrees.
Oh, we're just looking for like the degree wherever it is.
Yeah, wherever the second one lands, counting from the x-axis anti-clockwise round, we're trying to find it. Now, all these little 31s and little pieces that I've got here, they're just numbers that we use to help us find that guy. But the final answer would be 120, for instance, in this one.